Okay, assalamualaikum guys. So this is actually an ad hoc tutorial for those that will be having their quiz tomorrow on couple moments. Alright. So this is for a three-dimensional case. Right? And we're wondering how can we tackle such a problem here. So in this case we're given F1 is 100 Newton, F1 100 Newton, F2 120 Newton, and F3 is 80 Newton. What is the magnitude and the coordinate direction angles of the resultant couple moment? Okay. So the first and foremost thing we're going to do is try to draw the structure itself. So I'm going to draw the axis, right? So the simple free body diagram, not very complicated. So X, Y, and Z. Right. So I'm going to highlight the structure in blue. So we have a structure right here. Okay, let's going down. Okay, and it has a moment, right, which I'm going to draw it here, and this is caused by the force F3, right, and negative F3. Okay, and distance here is 0.2 meters. Now I'm also going to use a different color here, and we have a force here, okay, which is caused by F2, negative F2 and F2, and it's also 0.2 meters. Okay, and we have a force also F1 as well. Oh wait, let me just undo that real quick. So force F1, right, F1 also 0.2 meters. And last but not the least, we have another couple moment here, okay, that's acting at F4, yeah, so F4, okay, and F4 here positive. And the thing about this F4 is that it's an angle, it's 0.3 meters, okay, but there is an angle to it, right, which it makes, and this angle is said to be at 30 degrees. Let me just write that clear. Oops, sorry. This angle is said to be at 30 degrees, okay. And also this structure F4 actually, it's located at a point, right, that is 0.2 meters, and that is 0.2 meters, okay. So it also has a line that's parallel to it, and that's 0.3 meters, okay. If I can make sense out of it, it's 0.3. okay. So how we solve the problem? First and foremost, we try to find the moment vector for F1. Okay, so if we try to find the moment vector M1, okay, we try to find for M2, right, we try to find for, sorry, that's M2, yeah, M2 is purple by the way, M3 is supposed to be blue, and we find for M4. Okay, so how do we find for M1 actually? If you can see that the force vector, okay, when it multiplies 0.2 F1, it will create a moment, okay, that would be going in this direction. It will be going here, okay, it'll be going in this direction, which is inwards, if you follow the right hand rule. So meaning to say that if you follow the right hand rule, the moment vector is going to go in a direction parallel to the y-axis. So therefore, your moment vector at 1 would be what? Would obviously be in terms of the y-axis. Means I component would be 0, but your j component would be negative, right? It would be negative 0.2 times your f1. Okay, that would be your j component plus your k component, which is also 0, because if you follow the right hand rule, the moment vector m1 is actually going parallel to the y-axis. Okay, so it is actually going parallel to y-axis but negative direction. Okay, it's going to y-axis parallel but negative direction. Okay, so that's why your j component here is negative actually, and this one is because we use the right hand rule. Okay, so right hand rule for couple moments is very simple. You have a thumb here and this is all your other fingers. Okay, just pretend these are all your other fingers. So when you have a force right here due to a couple moment, the turning effect of the moment of this vector is obviously by the right hand rule, and therefore you will get your moment vector also, right, which will curl according to your thumb. Okay, so that's for m1. For the case of m2, okay, how do you get for m2? Because m2, it's circling this way, right? Oops, sorry, it's circling this way. So that is to say that your moment is actually going outwards here. m2 is going outwards. If you use your thumb, right hand thumb rule, you see that your thumb is pointing outwards to the positive x-axis. So therefore, it would just be f2 times 0.2, and it's a positive for the I component. And for the j component, it's 0, okay, because the vectors are heading in the j component, and your k component is 0. Okay, so far so good. So in this case, m2 is going parallel to x-axis positive direction. Okay, how about your m3? Now m3 is rotating like this, okay, meaning to say, if you follow your right hand rule, the vector m3 is actually pointing upwards. It's pointing upwards, okay, in the positive z direction. So your m3 would be 0i plus 0j, and how much k would it be? It would be positive f3 times 0.2 k vector. Okay, so in this case, your m3 is basically going parallel to z-axis positive direction. All right. Okay, so far so clear about m1, m2, and m3. But how about m4? How do we deal with m4? Okay, now that's the tricky part right here. For m4, actually, we have to take a little bit of a look here. m4, in this case, right, it's actually rotating in this direction, right? It's rotating in this direction right here, the couple moment vector. And the vector is actually going along this line. m4 vector is actually not going in any axis, it's actually following a line right here. This is the line actually that's going through, and this line actually has to be resolved into its x and y components. Okay, let me go to the next page and show you what I mean by that. So for m4, okay, for the formulation of m4, it's a bit interesting because the vector is actually going like this. Okay, your m4 vector, okay, it's going on this circle right here, and it's actually parallel to this line right here, where it's basically 0.2 and 0.2. This is 0.2 and 0, and this is, at this point, we can consider 0.2. Okay, let me just say this is 0.2. So what we can see here actually is that we can see a triangle, right? We can see like a triangle actually, right? And this triangle has an angle to it. This triangle has an angle to it. This is the y-axis and this is the x-axis in the negative direction. Okay? So you have to resolve the M4 vector into its y and x components as well. Now first, we need to first find the turning effect of M4, which is quite simply, right? It's just simply F4 times 0.3 cosine 30. Okay? 4 times 0.3 cosine 30, because remember that is just F4 negative, yeah, and this is 0.3 cosine 30, because it has to be perpendicular, remember? So that's why we put the cosine 30 right here. Now that cosine 30, I have to resolve into x and y components. So this is 0.3 cosine 30. Okay, and its x and y components would be what? This angle right here. This angle is actually tan inverse 0.2 over 0.2, which is obviously 45 degrees. So M4 would be negative 0.3 cosine 30. Okay, at this direction becomes sine 45, right? So it'd be sine 45. This is for your I component. Now for your J component, it's also going in this direction, right? It's also going in this direction as well. So it'll be negative 0.3 cosine 30 cosine 45 degrees J. And the K component is 0. Okay? Because when you resolve this M4 vector into the x-axis, oh my bad, sorry, because it's actually heading to the positive x-axis, alright, it's not negative, my apologies, it will be positive x in this case, but it's going against the negative y-axis, that's why it becomes negative y. So therefore you just reverse the signs, it just becomes positive, it becomes negative. Okay, so that is basically it for M4. Okay, it's a bit tricky, I know, because it's not lying directly on the xy line. It's actually not lying directly in x and y axes. Okay, rather it's parallel to a line. It's parallel to a line that can be expressed as a component of x and y. To make it more clear, let me just visualize it again. So this is basically your moment vector, right? Your moment vector, alright, is just 0.3 cosine 30 degrees, right? Your moment vector going in this way. Then you want to resolve it in its x and y components. It become negative 0.3 cosine 30 cosine 45, because we make an angle theta here. And this one is 0.3 cosine 30, right, sine 45. Okay, so this is going positive to the x-axis, so this one is going to positive x-axis, whereas this is basically going to negative y-axis. Okay, so once you have managed to get your four vectors M1, M2, M3, and M4, it should be very easy to determine the magnitude and the coordinate direction angles of the resulting couple moment. If you guys have any questions, feel free to ask me personally. Thank you. Assalamu alaikum.